Okay, can you hear me now? Okay, can you hear me now? Yay! Okay, that only took 152 years. Let's solder. What do you think? Alright. So, I've not tried this on camera before, and I have to reach my arms across the table more than I would like to. But we'll see how it goes. First thing up are the decoupling caps. These are 0.1 microfarad. Package size is 0603, which is small by really small. That's the metric measurements. Okay. Can you even see that I got the one little capacitor on there? Okay. Not sure why the audio wasn't coming through from the camera itself, but that's a mystery for another day. So, I gotta get this video cable out of the way or I'm gonna burn it. Okay, there we go. This is a weird soldering iron tip. It is a Pace mini wave tip for fine pitch components, and I'm still getting used to the sharp angle on it. The original Many-Wave tip is not this angled. But this thing has a little cup in the end of it. That'll be kind of hard to see on the camera. So just on the tip of there, it's not flat, it's got a little cup in it. So it tends to hold the solder. And it makes it really easy to do surface mount stuff. Phooey. Tried to make it better, and I just made it worse. And I made it worse again. Okay. That's relatively in the right spot. Now with that little cup in the end, you can wipe the tip of the iron off and drag it over something like that and pick up the extra solder. And I taped the board down to a larger circuit board that I drilled out to make a soldering fixture for soldering the legs on these guys. And the tape also keeps me from accidentally getting solder in the holes that the pins go through. Yeah, I cannot get used to this tip. It does work really nice for the chip itself. Oh, I just realized something doing this live like this. You guys are going to get the full effect of the stupid way that I tend to speak. I have this really annoying habit of stopping right in the middle of a sentence for an indeterminate period of time and not realizing that I'm doing it. And according to my daughter, it is very, very annoying. And I didn't realize I did it till I started making videos. And yeah, it is very annoying. Okay, oops, I'm getting that out of frame. It really bothers me if the components aren't on there straight. If the electrons have to go at an angle, it'll slow them down. Okay, well that's got way too much solder on there now, but they're stuck in place. So I'll add some more flux. The more the better. And we'll try to clean up all that extra solder. Gosh, bet that looks really goofy on camera with me spinning the board around at 100 miles an hour. Yeah, I think I might switch back to just using the little chisel tip for these chip parts. Okay, we got our extra solder cleaned off of those. So we've got our caps on. Now let me check. Oops, I've got my magnifier in the way of the stream there. So next thing I like to do is these two resistors right here. Put some flux on there, and then I'll check the comments. I guess I'll go ahead and get those resistors out. Those are these guys. These are 33 ohm resistors. There's one. Oh no, I dropped one. There it is. It is quite the disaster with these little parts. You sneeze and they go off into oblivion. Now I've got it stuck to my finger. Watching somebody make a mess of soldering has to be about as exciting as watching paint dry. I'm over here to see if you can see me. I'm over this way. You can't. Okay. I'm over this way trying to get the part unstuck from my tweezer. Okay. There's one part unstuck from the tweezer. The problem is all that sticky flux gets on your tweezer and it's a pain in the butt. Now let's check comments. Oh, video is not video. Well, it didn't help, did it? Okay, hopefully you can see that now. Okay, so I see where it says live, and I can see the picture. It's upside down from what I'm working on because of the camera, so. Okay, so. Now I had to unplug the StarTech capture box and plug it back in, so it probably made things funny. Okay, so can you see the picture now that I have parts on there? Okay. Well, those are caps. But it's hard to tell from that video. It's hard to tell when I'm looking at it under a magnifying glass too. The dangers of having old eyes. All right, so here we go again with some actual live soldering. I'll try to center up the board. As I was saying, these are 33 ohm resistors, although I cannot read them through my lighted magnifier. Stay down there. Okay. close-up of my hand. I'm using rosin paste flux for this, which is not really the best for surface mount stuff. It's nice in the fact it's kind of sticky and tends to hold stuff in place, but it gets all over your tweezers and stuff, and then everything just sticks and it's a pain in the butt. Okay, so I just put on these two resistors right here, which just go in the two clock output lines. Oh, come on, Jeffrey. This is at a place where I can get the camera to it, but it makes it hard for me to see. Okay, we'll just hold that one in place. Hold that one in place. And then we'll straighten them up. I guess the danger to this live streaming like this is I'm blabbering away, and if something goes wrong, I don't have any idea. Oh, goodness gracious. Yeah. Okay. As I mentioned, this tip is a new style, and it works great for the chips, like this T-SOP chip here, or S-SOP. But I'm not liking it for the little passive parts. So I might switch back to my regular tip. Just a little fussy. I like having these things straight. Okay, now we'll get the other side of those. But you can see how angled that tip is. You can't see the little divot that's in it. I find the angle rather hard to work with, except for when doing the ICs. Okay, those are down there. A little more flux, and clean those up. Now I'm placing about one part every 2 minutes, 3 minutes, and even an old 20-year-old surface mount machine would place, several of these little resistors a second. At my last employer, we bought some used Siemens side place equipment. And this was, 18 years ago, and it was used equipment then. And the machine that did these little chip resistors, I think each head held 8 or 10 of them at once, and there was 2 heads, so while one was picking up, the other was placing. It was just blindingly fast. Okay. Now I'm going to try something different this time. I'm going to place U2 here first. This is a little inverter. And I'm going to do that because once this resistor here, which is a 10K pull-up, once it's in place, it's kind of hard to get to one of these legs on this little inverter chip. Oh, I got to put some flux on there. It's sticking to my... So, a little more flux. Oh, you know what? I just looked over at my soldering stuff, and I actually do have some liquid flux in a pin, which I didn't remember. That would have made this easier. And this is where I wish I had a better angle, because I can't quite see over to see if I have it centered this way. So I will guess that I do. I don't want to get my magnifier too much in. Oh, that's my magnifier that's blocking the video there. And I should have plugged the camera in, I guess. Okay, so what we'll do is I'll get this tacked down. And I'll check and see if I happen to get it centered. Excuse me. I'll move the magnifier on it. Hey, that's not a bad shot, and it's actually the camera through my little lighted magnifier. Oh my gosh, and that's kind of blurry for you, but let me see if I can get that so it works for both of us. Alright, that is the camera going through the lighted magnifier, so we are both actually seeing the same thing from the same angle for once. Now I made it crooked. I didn't turn off the system sound, so you guys probably heard that I got email. It's not quite straight. Maybe if I rotate the board. So is everybody just glad that they gave away part of their evening to watch me solder badly and listen to me blabber? Doggone it. This is going terribly. Okay, I'm going to get this to where I can see it. I know that's screwing up your video, but I can't do both at once. Okay, there we go. Now you're looking back through the magnifier. I got this leg here tacked down. See if I can zoom you in a little closer on the board. Oh, blurry, blurry, blurry. Okay. See, this is where this tip comes in really nice. For doing these 3 pins on this side of this chip, I can just run it along there like that. And I just soldered all 3 pins at once. And that little cup that's in the end of this tip drags the solder along. But for the little passive parts, I don't like it as well. Okay, now we'll do this resistor. Let me check the comments first and see if you guys are bored to death. So can you guys see the... Oh, it stopped. The video stopped, didn't it? What in the world? Huh. Well, that's strange. It says it's streaming. Ah, how hilarious. So as soon as I start soldering and yapping and not watching the video, it cuts out. Okay, let's see here. Okay. Okay, let's try this again. I'm going to disconnect the capture device. And I'm going to Okay, well now you can see the other parts. Okay, can you see the board with more components on it now? And no. What in the world is it doing? Oh, okay. There's just like a couple second lag. Okay, woohoo! Streaming video that's actually video streaming. Who would have thunk it? Okay, now I'm going to try to solder the last resistor on there and we'll see if it keeps streaming. Oh my goodness. I can't handle all the excitement. Okay, the last resistor. This is just a 10K pull-up for that inverter. And I think it is pretty awesome they make inverter gates. One inverter in a single chip like this. That's too cool. Oh, hey, you know what? I'm going to plug my camera in because the battery's about dead. Okay, now the camera is plugged in, and hopefully the video is still live. Oh, DRMR, I think the interlace thing comes from the setting I have in OBS. I literally just installed it about 10 seconds before I started streaming, so I have no idea what I'm doing. Oh, yeah, it's the StarTech capture device. When it's used for streaming like this, for some reason shows up as an analog source, which is kind of strange. I'm not sure why. Okay, let's see if we can solder this 10K resistor on here. It goes right there. And so I had this all set up tonight because I wanted to try to do a good recording for a video showing how to solder these. And we'd been talking about streaming on Twitter, and I thought, well, why not try streaming while I'm trying to figure out how to solder this while recording it. And I really wish I had a proper microscope for doing surface mount work. It makes it so much easier. Okay, let's see if I can get my lighted magnifier in here. Especially now that I am old and I can't see. Okay. So hopefully this video is still actually video and not a still picture. The world's most exciting video stream. 10 minutes of monologue and still pictures at a time. Okay. So now I need to get the actual clock chip. Let me check the comments to see if we're still streaming video. Dr. Mister. Okay. Dreamer. Okay. I'll believe anything. Oh, I am building one of the MOS8701 replacements. It's the clock chip used in the Commodore 64 and 128. And mostly the stream so far has been me not knowing what I'm doing, trying to stream, and the video stopping and all sorts of fun stuff like that. And me blabbering along for several minutes at a time, not realizing the video isn't working, and everybody getting a big kick out of it. Okay, more sticky flux. Yeah, this board is about, well, let me get this up here where you can see it again. The whole spacing horizontally here is 4/10 of an inch, and I had to do that because this SOP28 chip wouldn't fit between a 3/10 of an inch spacing, and you know, for you guys in metric land, that's like 1,000 million milliliters or something, I don't know. Okay, and I like working on ICs this way. I actually ordered another set of tweezers today because the ones I have don't work as well for larger stuff. I used to have one of those little vacuum pickup things that was nice for things like this. And it left the building with Elvis at some point. Okay, a little more solder. And I used to be fairly decent. Where I used to work, we had a binocular microscope with a camera feed. And I used to be able to do this just under the camera feed. Come on, just tack one corner there. Okay, I'm going to slide the viewer right in front of it. Well, I kind of got lucked out there. That's centered nicely. Okay. So so the board is, let's see, that's 4/10 of an inch between those holes. The whole board is about 1/2 inch by 0.85, something like that. So I started wanting to make this board because I stole a, you see how I just drug that along all those pins? That is the beauty of surface mount soldering. And having that little cup in the end of this soldering iron. And now that I'm bragging about how easy it is, the video's probably stopped again. Now that I get to the side, I can actually see it's harder. Okay, well, add some more flux. If you have a proper magnifier, it's really not that hard at all, because you can see what you're doing. I've got a little too much on this side, so I'm trying to suck it back off there. There we go. Okay, now I'm going to put the magnifier back in your way. I'm surprised how well the camera does going through the lighted magnifier. I think the far side of that needs a little more flux. Oh, blurry. I'm getting in your way again. There's like this fine line between not having the magnifier in your way and me being able to see through it. Okay. I'm happy with that. Okay. So now we've got the components on the board. I need to take it off my soldering fixture here and clean it up a little bit, and then we'll solder the legs on. Let me check the comments. Oh, the tip is, it's by Pace. It's called a mini wave tip, and they have one that is, let me get it here where you can see it. That's this shape. So to give you an idea of scale, that is a 1/4 inch diameter, 6.35 millimeter. And these whole spacings are 3/10 of an inch. And I find this particular angle easier to work with. This tip is a mini wave tip, but it is for finer pitch components. It works better for this SOP28 chip, but I don't like the sharper angle and how much it sticks out of there. For doing the IC, it works fine. For doing these little chip parts, it doesn't work as well as the regular mini wave tip does. So, okay, uh-oh, I just heard something disconnect. We'll see if the video stopped again. I think it did. What is going on with my capture device? Huh. My capture device just quits capturing. Oh, you know what? It's this, it's the USB port it's plugged into. Okay, there we've got it back. Okay, well, at least we know what the problem with the capture device wonking out is. It's the front USB connector on my computer. I gotta run and grab some alcohol to clean this up. I'll be back in 2 shakes. Okay, got the alcohol. Yeah, there's people building new parts for much older stuff. Look up Curious Mark, the Curious Mark channel on YouTube. They restored an Apollo flight computer, and they made all sorts of new boards to interface with it to check it out and everything. One of the people working on the projects is a young guy working for SpaceX, and he made like an FPGA emulator of the Apollo flight computer. It was amazing. Okay, so I've got a little container filled with alcohol. And we're going to take our circuit board. This is the bottom of the board, by the way. And these pads are elongated this way because the pins are actually bent like this. And they go through the hole and bend and come up like that. So they come out at the correct 3/10 of an inch spacing. So I'm just going to drop that in there and swish it around. Oh, I just made a mess. It's out of frame, so I can deny it. Well, I guess it's mostly out of frame, but what the heck. I just like cleaning the board up a little bit before I solder the legs on. That way I can get a better view of it under the magnifier and see if there's anything I want to touch up, because that's easier to do before the legs are on. Okay. Clean up my mess. And note that the alcohol was for the board, not for me. Okay, you can't see me checking this out under the magnifier, but maybe you can. Maybe I can do it like that again. Oh. And we can both look at it under the magnifier. So yeah, the legs look okay on the IC. Little passive parts look okay. The inverter looks okay. So I think we're good to put the legs on. Yeah, I see, speaking of retro stuff, I watch a lot of different channels, and I see guys doing, like old PC stuff, the IBM 5150, and, even newer PC stuff, Windows 3.1, Windows 95 era. And that's kind of in the range where it starts losing interest for me. It's like, it's when computing became like, the hardware became a commodity that wasn't nearly as exciting anymore to see what was coming out. Okay, this is a fixture I made. It's 2 thick pieces of circuit board material that I drilled out on my CNC machine to make a soldering fixture. So the idea is I take the pins, before I do that, very important, slather this with some more flux, top and bottom. All the flux does when you're soldering is it helps remove any oxides, and it really helps the solder flow out better. It is your best friend. We slip the pins through there like that, and you see how they come out the, if you can see that, they come out the back and go in. And these are actually Arduino header pins, but it's the type that have a rectangular profile. So they're about the same cross-sectional dimension as an IC pin, although they look humongous on video here. And then this goes into the fixture like so, which is about 10 times harder to do on camera. Well, in retrospect, I should have made the holes in this fixture. I'm going to pick it up here. I know that's going to look wonky on the video. There we go. Should have made the holes in this fixture just a little larger, but it does a good job. It holds it right in place for soldering. And we'll push the board flat down, pull these in so they're standing up straight. Okay. So now I'll see if I can get this to focus in on the end. Maybe if I zoom out. Yeah, you can kind of see how that just holds it right like that. And we'll zoom back in. Okay, time to change out the soldering iron tip. Probably by the time I start soldering again, the capture card will stop. Alright. Well, for the pins, I'm just using kind of a small to medium-sized chisel tip. Give that a few seconds to heat up. Yeah, the surface mount production equipment is awesome. It's absolutely awesome. Even the stuff I worked with 20 years ago was amazing. Okay, so hopefully the video is still live. I think it is. Oh yeah, okay. It's funny when I do something and I look at the screen on YouTube, the streaming screen, it takes like 5 or 6 seconds to show. Yeah, you can use an old breadboard or some of that perf board that has 1mm holes. That works really good too. So for soldering these, this is going to be harder for you to see. Start out 1/4 at a time, and I've got this little chisel tip on here. Add quite a bit of solder, and I keep the iron on there about 5 seconds, and then I'll push back down and just make sure the board's seated in that corner. We'll do the same thing in this corner. And I gotta reach over to this side of the board. The problem I've seen people have the most when learning how to solder is they try to be too quick or have the iron too hot. Just got to give it time for the solder to flow out. Okay, so now that the four corners are done and the board's flat against the jig, now I'll just go and do all the other pins. I think if I try to record this part, I'll try to set the camera down on the table. I don't like the way that one flowed out. Okay, rotate it around here. I found a pretty good deal on a bunch of these clock chips, and I bought those, and I've got a bunch of circuit boards on the way, and I've got a bunch of these headers on the way. And I still need to order some more of the little resistors and stuff, but I thought I'll put these together in a kit. Everybody can solder together their own little clock replacement. I've tested these every way I can think of, and it is a much more stable output than the original 8701. And the only problem I've heard of is a problem with the C64 Reloaded Mark I, which has some sort of issue with how the crystal's set up. Okay, so now what I'm going to do is touch each one of these pins from the bottom and let the solder flow out. I'm going to have to look at this under the, see if I can get us both under the magnifier here. Okay, that'll work. Now we can both see it. Just want to make sure the solder flows all the way onto that elongated pad, so I'm just trying to touch the pad itself so I don't disturb the pin. Doing it that way makes for a very strong connection. Okay, we'll get the other side. It's interesting, the same time I was coming up with this, Passy did a different design, and Appy Paul did another design, and it was all basically, based on the same clock chip, but we all solved the mechanical problems in a different way. Okay. Well, if we look at, it's a little distorted because of the camera angle, but all our pins are nice and straight. I'm going to look at this a little closer under the magnifier here, and I am pretty happy with that. The solder flowed out really nice. Okay. Now, I think we can go out wider. Yeah, Tammy's my sister. One of my sisters. I have a lot of sisters. Oh yeah, it's on this, the clock on the camcorder's wrong. Yeah. Okay. I won't tell you how many sisters I have because nobody will believe me. So now I'm just clipping the pins off close to the plastic. When you're not trying to videotape this and learning how to live stream, if I do more than one of these at once, it doesn't take that long to do. You know, it's like anything else, getting set up, trying to learn how to live stream, failing, yammering on for endless minutes while there's no video. I realize I'm kind of blocking the shot by putting my finger like this, but it keeps the little lead from flying everywhere. Has anybody else but me started watching all the video that Vintage Computer Federation recorded of their virtual VCF festival this year? They had a lot of good presentations, a lot of interesting stuff about the ways some guys came up with to read in old magnetic tapes from computers back in the 50s and 60s and recover that data, and a couple great interviews with oh gosh, now I can't think of his name, and I just watched him today. The guy from Western Design Center that helped design the 6502. Anyhow, they're great. A lot of good stories from MOS and all that. I'm sure I was the favorite kid, because I was the best. I was the youngest. They stopped with me because, perfection. Okay, so we've got the legs on here. I do a little more cleaning in the alcohol. Now, I ordered bright red silkscreen boards. Or, no, I didn't. I didn't order the red, I ordered the blue. I know everybody likes black these days. I really do not like the black silkscreen because of the marketing guy from my last employer who insisted on doing black silkscreen or black solder mask with gold silkscreen because it was the company colors. It didn't matter that the products were in a can that nobody would ever see, and that our surface mount machines couldn't see the black circuit board, so they wouldn't feed through there. Because marketing genius. I never liked black circuit boards since then. So I thought the blue would be a nice compromise. Still colorful. I like the purple from these Osh Park boards too. Okay, so there we have a soldered together 8701 replacement. And my pins are nice and straight here. Does anybody want me to plug this into the testing jig? And we'll take a look at the oscilloscope and see if it works. Let's see, is the video still working? Yeah, I think the video is still working. Okay. get stuff out of the way so we can get the testing jig on here. Put up the extra soldering bits. Okay, so this is what the testing jig looks like. Show everybody what that is about. Give the stream a few seconds to catch up, and I need some power leads for the bench power supply. Okay. And these two center pins are just ground. And that is the reduced output. This is not a real 3M ZIF socket. It's one of the Chinese copies that falls apart when you try to use it. Okay, so this test fixture is basically the clock circuit copied from the Commodore 128 schematic except for the inductor. So I only wound up using two bypass capacitors here, and this 10 microfarads really not needed. I socketed the crystal, which isn't a really swift idea, but it makes a really nice crystal tester too. And you know, it required a socket to add that functionality, so why not? Yeah, this particular board here is one that I machined out. It was a real simple design. You can see, since the holes aren't plated through, you can see where I've had to solder in jumper wires here from side to side. So you wind up designing the board a little different because you can't put vias underneath things, and you've got to solder jumper wires through them, that type of thing. Okay, so this is the test board, and the power supply is set for 5 volts at 100 milliamps max, and this, oops, whoa, that was almost dangerous. I almost set it for 7 volts. Okay, now it's set for 5 volts. I have it set for 100 milliamps max, but really this chip draws like 10 milliamps. It draws about half the power as the original 8701. Okay, and got 10 milliamps. What is going on here? Oh, there we go. There's our straight through clock output. There's our divided output. I'll show you the scope here in just a second. Okay, well, this is about 50% functional, which I guess is okay for doing it on a live stream. Let me get the... I'm stepping on my microphone cable. Gonna have some shaky cam footage here. Okay. And my camera tells me it is panning too fast. So here we have the clock divided output, which would be the dot clock, and it's not working real well. But here is the straight through output at the crystal frequency, which is just fine. So I would say our clock chip is functioning. It's just something in that connection, like through R2 or something like that, something right on the chip, or something in my test fixture. So, but I'm semi-happy with that, considering I did it on a live stream, not knowing what I was doing on the live stream. See if we can get you back down here on the the part itself. So I will have to inspect this guy under more magnification to find out what the issue is. Try pushing on it here in the... Oh, you know what? It is a ZIF socket problem. Looky here. Yeah. Yeah, it's just a problem with this cheap ZIF socket. If I hold the handle just right, it makes connection and everything's hunky-dunky. So, okay. I will blame it on the ZIF socket, not my soldering skills. Ah, there we go. I just played with the ZIF socket enough. Oh, really good hairdo day. What do you think? Yeah, shaky cam. Yeah, zero performance socket, that's about right. Fire? Okay. Maybe on my second live stream we'll do fire. So, yeah, these Japanese copy, or Japanese, yeah, if it was a Japanese copy it would work. The Chinese copies of the 3M Tex Tool ZIF sockets are crap. They're cheap, but they're crap. So, but the clock chip's working fine. Okay. I think for a first attempt at a stream that wasn't too awful. It was kind of funny that it wasn't actually streaming quite a bit of the time. But we did successfully solder together a 8701 replacement. And I think officially now, well, yes, definitely officially now because I ordered the boards. The official part name is the MOS8701 HB. That was Finn Peterson's suggestion, so if somebody's looking for a MOS8701, that will show up in searches, which was a really good idea. And I just threw the HB on there because, you know, why not? And let me show you the back of the chip, or the board rather. So, well, you probably saw this before. Let me lay it down and I'll try to zoom in on it then. It's probably too much for the poor camera trying to focus on my ugly face and the circuit board at the same time. There we go. So I put thanks Sven P on there for Sven Peterson for answering lots of silly questions and things like that and making good suggestions. Thanks IZ8DWF. That is Frank in Italy. I actually saw him use the same chip and he made one of these on his YouTube channel. He does a lot of really good in-depth technical stuff on Commodore repairs. So I would recommend his channel. So I put both of those guys on there, and the final circuit boards instead of having the underscore HB, it's just a /HB. But other than that, they are exactly like this. So the kits will come with all the parts of the circuit board. I'll pre-bend the pins. Oh, I didn't show off the this is my bag with my fixture for bending the pins. So you unscrew these screws here. I didn't plan on doing this part, so I don't have it set up. Okay, I got to put you on the mount here so I can show how this works. Because of the there's only a 50 thousandths offset, which is 1.1 millimeters, and you can't really do that by hand. So let me get some pins. I'll show you how this works. So you start out with, we're still wobbly. Okay. I was just thinking, I think my dog is still laying upstairs in my chair. So you slide your straight pins into the fixture like that. And watch, I'm doing this and the stream stopped again. That would be my luck. Just push on it so the pins are up against this side. Tighten it down. Then you've got this part. I like doing one pin at a time to start with. And this, I'm just pushing down and it's putting the Z-bend on the pins. I really need to do this on a table that's sturdier than this, and then, yeah, this table's not sturdy enough for this. But that's the basic idea. This is what bends the pins into that Z shape. Here we go. Okay, we can do it like this. It took a little while to work out the width of this gap, the radius to put on the punch part here, because you can't bend the metal into sharp radius or it will crack, but you want it to be fairly sharp so it makes a nice tight bend. There we go. And now we have Z-bent pins. Yeah, half bright might be a good explanation for me. You've heard of Fulbright scholars. Well, I'm the half bright scholar. Okay, guys, any other questions before I sign off? So, oh, yes, I forgot to mention my other reason for trying this impromptu live stream tonight is I thought about doing one for the unboxing the 42 pounds of Commodore stuff that I got at the auction. I thought since it was 42 pounds and, and Commodore stuff, that was definitely all the answers to the life, the universe, and everything else. So maybe we can do that this weekend. I'm not sure what else in there. It might be interesting and it might not be, but. Okay, thanks everybody. Thanks for watching. Thanks for putting up with my fumbling and not knowing what I was doing. Have a good evening.